should be pointing to the new node we're adding to the sequence. So we're also going to say this dot tail is equals to node, which is the new tail. So we're going to call our length. So because since we're adding to the back, and as we're adding new value, as we're adding new nodes to our linked list, the length of our linked list should be increasing as well. So we're going to call our this dot length. And add an increment. So as our nodes are increasing, the length of our linked list is also increasing. And we're going to return this. So guys, this is basically how to create a method which adds to the back of the linked list. So the next thing to do is to compare the linked list push method to the array push method in terms of time complexity. So in terms of time complexity, we have different kinds of time complexity. So under the legal notation, we have O of 1, O of n squared, O of n cubed. We have many more many more big notations, but we're just going to be focused on this for today. So the O of 1 big notation, it basically doesn't have any iteration happening. So this any code that is O of 1 is basically in terms of time complexity basically fast, because no iteration has to happen in that code. So it's basically going straight to the point. While the O of n, it has an iteration going through, like our loops. We have while loop, for loop. So those loops are making an iteration to, for example, if we have an array, and we want to add a new element to the beginning of our array, and our original array has indexes of 0, 1, 2, 3, and 4. And we're planning on adding a new element to the beginning of our array using the onShift method. So let's say the new element we added was 9. So an iteration has to happen over here, whereby the onShift method has to iterate through the array and change each of the indexes. So that is what the O of n notation is basically about, a single iteration happening in the code. So to the O of n square, as its name speaks already, has a double iteration happening. And in the case of you having double iteration is with your higher order methods like map, filter, reduce, sum, even, and so on and so forth. These guys have double iteration because they are taking a function as a parameter. So what is common between all our other methods is their callback function. So since they are taking a function as a parameter, a double iteration has to happen in this function. And another instance of O of n squared is our nested loop. So having a loop inside the loop, so it will have a for loop. So this is a double iteration because it has to run, it has to iterate 3 times. First of all, this code has to run, and then this code has to also run before you get to result. So the double iteration is happening. So speaking to the now, I'm going to be speaking to the open cube as the name implies triple iteration that's going to be happening in your code. And another instance of this is also your nested loop, whereby you having two loops inside a single loop inside each other. So you have your for loop, another for loop inside, another for loop. This can basically be any loop, which since as long as it's an iterator, it's just showing that I'm just using to explain the open cube notation. So moving to that, let's go back to our topic for today. So in terms of array, using the push method to add new elements to our array to the back of our array, this notation is known as O of 1. This is because since array has indexes, adding a new element to the back of our array doesn't really make a difference to that array. It just increases the length of the array, but the indexes or the other elements in the array is not affected, because this is basically just adding a new element to the back and giving it a brand new index. So no iteration has to happen, whereby the push method has to iterate through our code to check or to change any index position of any value in our array. So in terms of time complexity, the push method on that array is all 1. So now we are going to be speaking to the push method on that linked list. The push method, the notation for the push method on that linked list is O of n, because an integration has to happen. So our linked list, the main difference between our linked list and our array is array has indexes and linked list has pointers, which are the tails. So in your linked list, you having, let's say, 5 nodes. 5 nodes. And remember, linked list always starts from the beginning, which is the head node. Linked list always starts from here. So you wanting to add a new node to the back of our linked list. The linked list first of all has to check through the list and see. So how do you know? Does the linked list know where to add the element? So the method basically iterates through the list and checks which of the lists have their tail pointing to null, because only the tail node has its tail pointing to null, and we need to add the new elements at the back of this linked list. So an iteration has to happen, and it only iterates once. So it's a O of n notation. So when it iterates through, it checks each value. When it checks this value, it goes to the next. It holds this value in its memory, then move to the next one. Still holds this value. Check until it meets the one that meets up with the starting condition, then adds the node to the sequence. So in terms of time complexity, with the push method under linked list, the time complexity is O of n. So now let's move on to the next method. The next method we're going to be looking at, still under our class